Are we ready, everybody? Okay, good. All right, let's get our notes out and work along with me, please. Okay. All right, so first of all, this whole topic has to deal with concentration. Okay, so concentration, how concentrated a solution is, how dilute a solution is. We use molarity, and then we also used molality. So molarity we saw in Chem 1. It's moles of solute over liters of solution, also known as big M. Molality is something new for us here in Chemistry 2. It's moles of solute, kilogram of solvent. Okay, usually that solvent is, what will the solvent be? Okay, usually that solvent will be water, right? Water. And furthermore, if the solvent is water, furthermore, if the solvent is water, what do we call that solution? Okay, aqueous, okay? From aqua, water, aqueous. Right, so we're going to have here 44.6% mass, 44.6% by mass. 44.6% by mass, sodium chloride. Okay, just so you know, sodium chloride is NaCl. Can you hear me in the back? Yes, good. Right, so 44.6% by mass. Okay, by mass. This means, okay, first of all, what's our solute and what's our solvent? Water, okay, usually it's distilled water. And what's our solute? Okay, this will be our solute. Okay, so 44.6% by mass basically means this. Okay, it means we have 44.6 grams of NaCl. Okay, it's a percentage. Percentage is part over whole. So part solute. In the denominator, we're going to put the whole thing. What does this whole thing contain? It contains the solute, 44.6 grams NaCl, and it contains the solute. Okay, what is our solute? Water. But how much water will it have? Okay, usually it's by 100, right? 100%. So 44.6 parts NaCl. What would be the other part water if it's 100%? Okay, we'll subtract 100. And what do you guys get? 55.4 grams. So this is what this means, okay? 44.6% by mass. NaCl is 44.6 grams of NaCl divided by 100, okay? But that 100 is 44.6 grams of NaCl and 55.4 grams of water. That's what this means. Okay? All right, so the question is molality. Okay, we know what molality is. Okay, this is something you should know for the exam. It's moles of solute over kilograms of solvent. Okay? Moles of solute over kilograms of solvent. So our solute is NaCl. Let's go ahead and convert that to moles of NaCl. Okay, 1 mole of NaCl contains how many grams of NaCl? Remember how to do this on your calculator. Okay, you'll add up the numbers. Okay, so this is going to be about 23 grams, 23.01 grams. What would Cl be? About 35.45 grams. So I'm going to add 23.01 Na, 35.45 Cl, okay, and I'm getting about 58.40 grams. So you add those numbers to get the molecular weight. So 44.6 grams of NaCl, 1 mole of NaCl is 58.4 grams. We just add those numbers in the periodic table. Grams and grams cancel. I'm getting, what did you guys get? 0.764 moles. Did you get that, Allison? 0.764 moles. All right, so 0.764 moles. Okay, kilogram of solvent. Our solvent is water. We'll just convert that to kilograms. Okay, so this is our solvent. Okay, convert it to kilograms. We'll move the decimal place 3 to the left. 3 to the left. So 55.4 grams of water, distilled water, deionized or distilled water. So kilograms of solvent for molality. Kilograms is 1,000 grams is to 1 kilogram. Okay, that's the equivalence. So grams and grams cancel, and that's 0.554 kilograms. Kilograms of solvent. Water will, 99% of the time will be our solvent. Okay, moles of solute, kilograms of solvent, and let's divide those two up. Okay. So our new molality is going to be 0.764 moles of NaCl divided by 0.554 kilograms, I'm sorry. 0.764 divided by 0.554 kilograms. Go ahead.
I got 0.055.
Yeah. Not 0.5.
1, 2, 3. Yeah. All right, my bad. Thank you. Appreciate that. Thank you, Alex. That is 0.0554. Move it 3 to the left. 1, 2, and then another 1, 3. Yes. All right, thank you. So 0.764 divided by 0.0554 kilograms. Okay, what did you guys get for that? 13.8 or something around that? 14? 14, okay, 14, 13.8. I'll do 3 sig figs, so 13.8 lowercase m. So this is our answer. All right, good job. Thank you for catching my mistake. 13.8 molal. You got that, Asia? 13.8, 14. That's good. All right, let's do one more molality problem, since that's a little bit difficult. And we'll do that one, and then we'll move on to the next topic in this chapter here. Okay. A solution of H2SO4. This is called sulfuric acid. I do not know if you remember this from Chem 1. Sulfuric acid has a molal. We'll call this lowercase m of 8.010 molal. This is the density of that solution, and we're asking for molarity, moles over liter. Moles over liter. So what is our solute? Our solute is going to be H2SO4. Okay, what will our solvent be? Our solvent will be water. Okay, good. Okay, deionized distilled water. You can put water. It's fine. Okay. Okay, that lowercase d stands for distilled or deionized water. Just means like pure water. Are we ready to do this problem now? Okay, what does 8.010 lowercase m mean? 8.010 moles of H2SO4 over what? Okay, moles of solute over kilogram of water, kilogram of solvent. That's what this lowercase m stands for now. So 8.010 molal is 8.010 moles of solute, kilograms of water. Okay. I put the D here just to say it's distilled or deionized water, just pure water. Okay. Moles of solute, kilogram of solvent. 1 kilogram is the same thing. Okay, 1 kilogram, look at this here, 1 kilogram is the same thing as 1,000 grams of water. Okay. 1 kilogram is the same thing as 1,000 grams of water. And as Allison mentioned, our water will be our solvent. This, as Allison mentioned, H2SO4 is our solute. And I'm going to go ahead and convert this to grams. Okay, let's convert this moles of solute to grams of solute. So 8.010 moles of H2SO4 times 1 mole of H2SO4. Okay, I've already calculated the mass of this. Okay, you just add the numbers, right? 2 times the hydrogen, 1 times the sulfur, 4 times the oxygen. Remember, you did this in Chem 1? All right, so I added those up together just to save some time, and I'm getting about 98.03 grams. Okay, adding the 2 hydrogens plus the sulfur plus the 4 oxygens, about 98.03 grams of H2SO4. Yours may be a little bit more, a little bit less, that's fine. So the moles of H2SO4 cancel with the moles of H2SO4. And how many grams is this? What did you guys get? 8.010 times 98.03. Shall I calculate it, or I'll let you guys calculate it? 790? I got 785.2. We'll go with that one. Okay, this is the grams of our solute. This H2O, which will always be our solvent unless told otherwise, this is our grams solvent. Now, what do we know about a solution? What makes up a solution? Solute and? Okay, so I'm going to say the grams of solution. Equals grams of solute plus grams of solvent. Solute plus solvent, solution. So our grams of solute, we calculated this as 785.2. Our grams of solute, our grams of solute is 785.2. Our grams of solvent is 1,000. So what do you guys get when you add those up? 1785.2. 1785.2. Yep. Very good. So this is the grams of solution. Okay. So we got our grams of solution. We just need to ask ourselves, what are we trying to get here? Okay. We're trying to get molarity. And what is molarity? Okay. So on the test, a good multiple choice question, what are the units of molarity? Okay, you'll say moles of solute over liter of solution. Okay, but we've got grams of solution. Okay, we got our moles of solute, which is fine. But what about our liters of solution? How will we get that when we have grams of solution? The density, okay. So from the density, we should be able to get milliliters of solution and then liters of solution. So we'll use the density. So 1785.2 grams of the solution times our density. Okay, I'm going to put the 1.354 at the bottom. Okay, to get my grams to cancel. Mils will be up on top. And then the conversion to liters is 1,000 milliliters is 1 liter. You guys see that? So using the density here, I'm getting my volume of solution. So what's 1785 divided by parentheses 1.354 times 1,000, close parentheses? Uh, 1.3185. Got that? Yes. 1785.5 divided by 1354.
So that's 1,000.
1 liter is 1,000 milliliters. That's correct. And that's the conversion. 1.3184, 1.3185. I see a net. I see a nod. So 1.3185 liters. Okay. Finally, we can get the answer. Okay. Moles over liters is molarity. So what is our moles? Oh. What's our moles? 8.010 moles. Okay, what's our liters? 1.3185 liters. Big M is moles over liters. What do you guys get when you divide the moles over liters? .07. 1, 2, 3, 4. 1, 2, 3, 4. Maybe 6.075. Okay, what are the units here? 6.075 moles over liters, 6.075 big M, which is the same thing as moles over liters. Okay, so this is how we do that conversion. It's a long process, but this is our final answer. I did 4 significant figures because this is 4 significant figures and that is 4 significant figures. But on the exam, if you put 6.08 or 6.1, I think it should be fine. All right, so we did on Monday a lot of these conversions. We did a couple of more today. These involve concentrations. Okay, I think the homework should have some practice problems. There's some videos that I posted should have some practice problems. We'll have a review on Wednesday with more practice. Okay. With your blessing, I'll move on to the next page. We're going to skip page 5 and 6 because of time. So we can skip 5 and 6. You can put an X over that. All right, and let's talk about colligative properties. This is something we mentioned at the very beginning of this chapter. Can anybody name the 4 colligative properties? Okay, what happens if you add a solute into a solvent and make a solution? What 4 things happen? Well, yeah, anybody can name the colligative properties? Okay, we have a new vapor pressure that is lower. We have a new boiling point that is higher. We have a new freezing point that is lower. And the biology people, if you put a membrane between, put a membrane somewhere in between, what will you have? Okay, osmotic pressure, which means water is going to rush through the membrane. Okay, will rush through the semi-permeable membrane. So this is what happens. Okay, let's do some problems here. Okay, I'll give you all the equations. Okay, I'll give you all the equations. The first one, the first colligative property I want to talk to you guys about is the vapor pressure, as we mentioned, is going to lower. And this is the equation. This is the new vapor pressure of the solution. Okay, I'll give you that equation. You do not have to memorize anything as far as this is concerned. So we add a solute into a solvent. We have a new vapor pressure, which is lower. And that new vapor pressure is this solution. Is that a train? I could swear I'm hearing a train. I never heard a train before while lecturing. So the new vapor pressure of the solution is going to be the mole fraction of the solvent times the vapor pressure of the solvent alone. So let's write this down here. This is mole fraction that little cursive X means mole fraction. Mole fraction of the solvent. Anytime you see fraction, anytime it's a fraction is part over whole. So part solvent. Okay, part whole. What is the whole thing? Solvent plus solute. The whole thing is solution, you're right, but the solution is solute plus solvent. Okay. And this P naught, I don't know if you know that.